Hello, welcome to this video. So this video will be about a conventional question in paper 1 of DSE about geometric sequences and more about probability. Ada and BD play a game consisting of 2 rounds. So in the first round, so this is in the first round, part A. First round, Ada and BD take turns to throw a fair dime. The player who throw first guess at number 3 wins the first round. And Ada and BD play the first round until one of them wins. Ada throws the die first. Okay, so that's why the first round is Ada. So either a 3 or not 3. Okay, so getting a 3 would be, in the fair die, would be 1 out of 6, 5 out of 6. And in the second round, so if Ada take, then that's the end. But if not, so that will be take cross. That will be BD turns. So against 1 over 6, 5 over 6. And then Ada again. Take cross. And just continue. So the required probability for Ada to win the first round. So either Ada gets the number 3 in the first round, or in the third round, or in the fifth round. Until the end of the world. Okay. So she may get the number 3 in the 2000 first round. So anyway, so and then if Ada gets the number 3 in the third round, provided that she, for example, okay, in this case, third round, provided that the first round Ada cannot guess the 3, and then in the second round BD cannot get the number 3, and then in the third time, okay, I will try to use the time because here we have 2 rounds, okay, for the game, right? And then for the third time, Ada finally gets the number 3 so as to end the first round. And then so for the first round, so 1 over 6. Okay, if for the first 2 rounds cannot get number 3, so that will be 5 over 6 times 5 over 6, and then 1 over 6. Using the probability of using the multiplication rule of probability. And for this, okay, so that will be 5 over 6 times 5 over 6 times 5 over 6 times 5 over 6 times 1 over 6. And then if we try to reorganize the products, so that will be 1 over 6 first term. The second term, that will be 5 over 6 and then square, then times 1 over 6. This is 5 over 6 to the power 4. So you can see this is a geometric series. So you may describe it as summation, or the sum of the first, this will be sum to infinity of a geometric sequence. Right, so that's why in this case, we try to use A over 1 minus R. A is 1 over 6, of course, and then R, that would be 5 over 6 all squared. So using the calculator, so that will be 6 out of 11. And that will be for part A. Right, so for part B1, so in the second round, balls are dropped one by one into a device containing 8 tubes. Arrange them side by side. When the ball is dropped into a device, it falls randomly in one of the tubes. And then at that same point, each tube can hold at most 3 balls. So, option 1, 2 balls. That's important. 2 balls are dropped one by one into a device. If the 2 balls fall into the same tube, here we have quite a number of rules here. And then for B1, so we are assuming if the player of the second round adopts option 1. Okay, so option 1 here. And then find the expected number. The expected number of the tokens. Okay, now so we need to have the probability of each case. So that's why here we have either getting 10 tokens or 5 tokens or no tokens. We need to get all the probability. Right. We need to figure this. Token. Either 10, 5, or 0. And the corresponding probability. Okay, so probability of getting 10 tokens, okay, if the 2 balls fall into the same tube. Now, so here I think the key idea, now listen, the key idea, now there are 8 tubes here, so I'm going to name them as 1, 2, 3. The first tube up to the 8 tubes, and then if 2 balls are dropped one by one into the device, that means, okay, we are going to have a 2-digit number, and then, okay, we're trying to think about, how many 2-digit numbers can be formed according to a certain weights. So here, the 2 digits, okay, the denominator. So since, okay, the 2 digits can be repeated, okay, because the 2 balls, okay, can fall into the same tube. So that's why for the first case, okay, so we will be trying to have, right, so we can have 11, 22, 33, 44. So by counting, already we can get all the 8 cases. And then for the denominator, so it will be from 11 to, it can be 11 to 18, and then 22 to 28, 33 to 38, right? No, I mean, we can have a table. We can have a table. So just try to think about, yep, like this. 1, yep, just like this. And it can be 11, 12, and then up to 18, 21, 22, and then with a table. Understand? So that's why for the denominator is not so difficult to get. That will be x squared. Any problem? And then for the second case, what will be that? That will be if the two balls fall into the two adjacent. So 5 tokens. So in that case, okay, we'll try to look at, that would be the case, that would be that would be 12, 1, 2, and then 23, 34, 45, 56, 67, and 78. Now, so here, if you try to count the number of cases, so that will be 1, 2, 3, 4, 5, 6, 7. So that's why for the second case, okay, so the numerator will be 7. There will be 7 cases, and then it may not be just 1, 2, or 2, 3. It can be swapped. Okay, so it can be 1, 2, and 2, 1, 2, 3, and then 3, 2. So that's why 7 times 2, or 7 times 2p2 is the same, and then over x squared. And then for the third case, okay, so that will be 1 minus. But it does not really matter because a 0 token. Okay, so it will not be. It does not matter. Okay, in the calculation of expected numbers. So that's why for B1. So the corresponding expected number of tokens. So that would be 10 times x over x squared, and plus 5 times 7 times 2 over x squared. And that would be 75 over 32, or in decimal, so 2.34375. And that would be for part B1. So and then for B2, here we go. Which option should the player of the second round adopt in order to maximize the expected number of tokens got? Also for the expectation of the expected number of tokens, okay, in the first round, so that would be 2.34375. So that's why, okay, of course here we need to find the expected number of tokens, okay, we can get if we try to use option 2. So that's why we need to look at option 2. So this time we have 3 numbers. Okay, so but before we look into that, okay, so it could be either 50 tokens, 10 tokens, or 5 tokens, or 0. So that's why so just like okay, in B1, so tokens and then probability. Okay, it could either be 50 tokens, 10 tokens, or 5 tokens, or 0. Right, so and then for here, the denominator. So since this time, okay, 3 balls are dropped one by one, so that will be 8 cube. Right, so just extend, okay, using the multiplication rule of probability. Right, so and then for this time, if 3 balls fall into the same tube, 50 tokens. So again, it's easy. So just a case, and then we can already name it 3-digit number this time. So that's why just 8 cases, easy. And then for the second case, it will be 3 balls fall into the 3 adjacent tubes. So again, the adjacent tubes, 10 tokens. So it's just like in option 2. We try to think about this. Right. So it could be 1, 2, 3, the first case, 2, 3, 4, second, third, and then fourth, fifth, and then sixth. So that's why, okay, if in option 1, so that's 7, so this time we have 6. And then don't forget for 1, 2, 3, it could be 1, 3, 2, it could be 2, 1, 3, it could be 2, 3, 1, it could be 3, 1, 2, it could be 3, 2, 1. So we need to times 6, okay? Or we try to times 3p3. That's the same. So and then that would be for the second case, 10 tokens. And then finally for the last case, or the second last case, 3 balls fall into 2 adjacent tubes. Okay, so that may be the most difficult case. Here, again, we try to use the numbers. Okay, so first of all, okay, it could be 1, 1, 2. Okay, so just like this, and then some arrangement, and then it could be 2, 2, 3. So 1, 1, 2, and then 2, 2, 3, and then you can see that will be 3 to 4. Fourth case, fifth, sixth, and then 7. It could be 7 cases. And then don't forget this time we have 1, 1, 2, and it could be 2 to 1. Okay, so it's the same. This is 2 to 1, or this is 3, 3, 2. Okay, and then after that, don't forget we have this time for each case. Okay, so it could be 2 to 3, and for 2 to 3, it could be 2, 3, 2, and it could be 3, 2, 2. It's the same combination. Right, so that's why times 3. Right, so that would be the number of different 3-digit numbers. Okay, so with this kind of requirement. So and then you can see for 0, so just 8 cube minus 8 minus 6 squared, and then minus 6, 7 times 2 times 3. Well, anyway, so just 1 minus 0. So that's why here we go to then so the expected number of tokens using option 2 can see that would be 50 times this. Just do the lump sum. Let's see. So the number is quite low. 485 over 256, and that would be 1.089453125. And then you can see it's less than 2.34375. So that's why, okay, if I were the player, okay, in the second round, so option 1 should be adopted. So remember that. So option 2, okay, we'll try to use option 1. So remember the expected number of token, and that will be B2. So finally, in the last part, B3. So only winner of the first round plays the second round. It is given that the player of the second round adopts the option which can maximize the expected number of tokens cards. So that will be option 1. So that's why, okay, we will look at option 1. So BD claims that the probability of ADA. Okay, so ADA, first of all, ADA. So that means ADA will win the first round, and then getting no tokens. Right, so that's why here we'll try to find probability that ADA gets no token, and that will be equals to 1 minus the probability ADA gets some token. So ADA can play the second round, but whether ADA wins the first round. So ADA wins the first round, the probability is this, 6 out of 11. And then if ADA in the second round, she can get some token. That means, okay, she can either get 10 tokens. So the probability of getting 10 tokens is 8 of x squared. So that will be 8 of x squared. Or she can get 5 tokens in the second round. So that will be this. 2 cases. Let's sum them up. Then let's see, this probability, would that be bigger than 0.9? And then times 6 out of 11, 1 minus, and that would be 0.125. So which is less than 0.9. So that's why the claim is not correct. And that's all for the last part as well as the video. Thank you for watching.